right, so we're gonna continue digestion. And I just wanted to kind of go over it a little bit before we move on. The functions of the digestive system. So what's prehension? What was the video of prehension?
How they collect food into their mouth.
Yeah, remember what animal it was that it was the video of? No. Alright, then we're gonna do something. I need a volunteer. Carly, come on over here.
You gotta do it in front of the camera.
Alright, take the mask off. Alright, put your arms behind your back. I'm scared. Alright, grab it with your mouth. Good. Well, now wait, don't. What did she just do? What stuff was that? Prehension. So what did she do? She grabbed it with her lips, and now it's in her mouth. All right, go ahead. Step 2. Show the camera.
You're not in the camera.
What is she doing now?
Chewing.
Chewing. What's that called? Mastication. So what does that do to her starburst?
It breaks it down.
It's breaking it down with her teeth, right? So smaller pieces. And what's happening in your mouth right now? What do you feel sloshing around? Saliva. Okay. So the saliva is also helping to start break it down, right? And it also does what so that it can move down her esophagus?
It lubricates
It lubricates the starburst, okay? I mean, at least starburst, it's better than swallowing a chip with no saliva, right? All right, go ahead and swallow. Did you swallow it all?
Mm-hmm.
All right, you feel anything?
No.
You don't feel anything? All right, have you ever swallowed a pill or something and you feel it scrape all the way down? Okay, you can sit, my dear. Thank you for...
I like feeling hot soup like going down your esophagus.
So you feel it, like when you swallow, going down your esophagus in a weird situation, right? She didn't feel the starburst because she chewed it for a really long time because I made her chew it for a really long time. We lubricated it. All right, so step 3 is chemical digestion. Where does that happen? In her stomach. Okay, so that's what we talked about, that hydrochloric acid breaking that starburst down. And that's going to start to happen, I don't know, in a minute. I'm sure by now it's in her stomach. The starburst is in her stomach. Okay, Carly? Now, let's give it another hour. Okay? And that starburst is going to be in her small intestines. Alright? And that is where we start to absorb whatever small nutrients are in a starburst. Right? Yeah. Whatever we need from it, and water. And then, well, Carly, we're not going to videotape this, but eliminating waste. That would be funny. We won't show an after picture. All right, what's an herbivore versus a carnivore? Plants versus carnivore, just meat, right? And then omnivore is us, well, most of us. A little bit of both, right? All right, and we are, what is this word, mono? One? Gastric, what's that? Stomach, one stomach, and then we're going to go into some others later. So we started monogastric. We had the upper GI tract. What's the first thing that we have? Before the esophagus, what's all this junk? The mouth, right? So we've got a lot of things going on in the mouth. Then we have, what's the pharynx?
The little thing that opens and closes.
That's part of it. It's just the throat, okay? It's just the throat. And then we have the epiglottis that closes over the trachea so we don't aspirate. Then we have the Lexi. What's after the throat?
The
Esophagus. And then it goes kerplop into the stomach. All right, so let's go over that. Did you run your tongue on the roof of your mouth? You had the hard spot towards your teeth. Now take your tongue back towards your throat, and it's like, ooh, now I'm into soft land, right? Those are your palates. Carly said she felt saliva swishing all around her starburst. How did you move your starburst from side to side? You gotta use your tongue, right? Your tongue moves it from one side to the other to chew it, and then it moves it back to swallow, right? And then she's got her teethers. Did you listen to my story about the cracker and you spit on it?
What?
Did I tell you that?
Yeah.
You spit on the cracker and like a big old spit, and then you wait like till the next day and it actually starts to break down because of the enzymes in your saliva. So your saliva actually starts to break down your food before you even swallow it. Talk about the tongue. Enamel. What's the second hardest tissue in our body? Enamel is first. Bone is the second. Okay. Have you guys had a cavity before? Have any of you had a cavity? And they had to fill it, right? So a cavity is a hole in the enamel. That's why I call it a cavity, right? Cavities are openings that hold something. So coffee, eating like through the day, like candy and gum all day long, it actually breaks away because your saliva breaks down your enamel the more and more and more that you have it swishing around there. What's gingiva? Fancy word for what? Your gums, right? Surrounds your teeth. And then we talked about teeth. Okay. You guys want me to get one of my skeletons down, or can you kind of picture how these are pointed backwards to grip something and keep it?
We took a picture of the deer's teeth.
Awesome.
We were gonna show you, but we didn't get that far.
Okay, great. Yeah, I'd love to see it. So look more like this, right?
Yeah.
Flat, grinding. You guys didn't see the horse teeth, did you?
No, you showed it to us. That was you.
So nice ridges here. This is a horse's tooth. Ridges here to break down all of that plant and green material. Okay, then what are these teeth right here? Incisors, canines, way in the back,
Molars.
and then premolars. Good. Pharynx is our throat, and it's a combination of air and food, right? We have our respiratory tract in that, because can you breathe through your mouth? Plug your nose. Now breathe. Are you still breathing? Yeah. My mask is like coming into my mouth. Okay? So there you go. There's your proof that it is two systems. Okay? And then how many of you have choked on a beverage or something that you're eating? Someone made you laugh, right? So there's further proof that food can go into the trachea and you cough it out. Okay? If you don't cough it out, it goes into your lungs and then you get pneumonia. Esophagus. We're just directing food from the throat and into our stomach. Then we have our stomach. So storage, acids, breaking that starburst down, which is happening right now. Okay, it sits in there a little bit, right? It sits in there a little bit. It's got to break down. Then we're going to move to the lower GI tract, which we're not going to have Carly show us because that just gets awkward. It includes the small and large intestine and the anus, but we're going to go farther into detail for those. All right, let's start with the small. So the small intestine is responsible for absorption. So this is, I don't know, if you ask me, it's one of the most important parts of it. Those who have like irritable bowel disease, okay, they don't absorb their food very well, and so a lot of times they find it difficult to gain weight and keep weight on. That's because the food just moves right through, and they don't have time to absorb the nutrients. So those nutrients go into our bloodstream, into our cells, and our combining form is entero. Entero. Does look like Wilson, except he's normal size. Alright, large. There's a lot of portions of this. So, we've got the cecum, the colon, the rectum, and the anus. I thought there was more. Okay. Alright, so the cecum is kind of strange. The cecum is all about enzymes that break anything that's left over from the small intestines. Okay? They break it down in a way that our body can absorb those nutrients. So the cecum, when we start talking about horses, is going to be even more important. And humans, don't get me wrong, it's very important, but horses, it's like tenfold. Alright, colon. You guys have heard of a colon, right? If any of maybe like your dad is old enough, they probably had a colonoscopy. Did you hear that? And they're like crying because the prep is so awful. They have to clean themselves out, take this nasty drink, and they just lose everything. But the reason is a lot of men who are older than, I don't know, I think they start at like age 40 now, they have a lot of problems wrong with their colon. Colon cancer is really common in men. Polyps, so like overgrowth. So the colon is responsible for removing water. Alright, and here's where Mrs. Cook is a weird teacher, because instead of leaving it with that, I'm going to make you connect to this, okay? If you have diarrhea, what's the consistency of that stool like? Water. So where did it not sit long enough? It didn't sit in the colon. Right? And that's why it was so liquidy, is because the colon didn't get a chance to remove that water. Alright, if you're pooping pebbles, marbles, do you have enough fluid? You're dehydrated. Okay? If you're a marble pooper, then you need to drink more, because that colon is extracting so much fluid, trying to give your body more water, that what you're left with are these dry little marbles that are hard to come out. Okay, constipation. So you need to drink more, you need to be more hydrated. Okay? The rectum. The rectum is our storage spot, and this is where it says, oh my goodness, Coke, I need to go to the bathroom and defecate. Okay, this is where your nerves are that say it's time. When that rectum starts to get fuller and fuller, the nerves are triggered to say, I gotta go poop. Okay, so then you go to the bathroom and it leaves into the toilet, right? Hopefully. So that exit, I think anus exit. A-N-U-S is 4 letters, E-X-I-T is 4 letters. The anus is your exit, it's an opening, and that's where your fecal material leaves. Okay? Alright. So, you've probably heard of all those things. Maybe not anus. You've probably heard some people say, like, rectum used incorrectly, like you defecate out of your rectum. It's not really accurate. But we still have some weird organs that we haven't talked about, alright? And they are kind of interspersed through this whole system. You guys have heard of the pancreas before? What's that deal with? Insulin, sugar, diabetes. Okay? This is, this is an organ that secretes enzymes as well. But one thing that it secretes hormone-wise is insulin, and that helps us decrease those blood glucose levels. Liver we've heard of, right? So the liver produces bile, and that helps us break down fat. You all have your gallbladder, right? Okay. One of my students doesn't have her gallbladder, and she has a hard time with fatty foods. She gets really sick to her stomach and nauseous because she doesn't have bile to break that food down anymore. Okay? The liver also is similar to a filter, so it takes out toxins, anything that the body perceives as unnecessary or bad for it, and removes those items. And then our gallbladder is our liver's best friend. That just stores the bile. Have you ever thrown up like so much that finally you throw up and it's like this greenish, yucky, nasty material? That was bile. That's because you had nothing left in your stomach. Or if, like Rocky, let's say, well, Potter's probably a better example. He didn't get fed for some reason. Maybe, for example, if you have like a dental coming up, so you couldn't get fed that night, and you're like so hungry, and you throw up because you're so nauseous because you're so hungry. A lot of times it's like that yellowish green bile. Okay. So our gallbladder is right here, and it just stores that bile, and it just is like a little squirt as needed to break down fats. Okay. There's our pancreas. All right, here's Carly's esophagus. So peristalsis is our muscle surrounding really our entire digestive tract, especially like her esophagus, because she said that she didn't feel that starburst go like swallow, you didn't feel something like drop, right? It slowly moves down, and it's a motion like this, wave-like, really fluid. That's how, if we sent Carly to outer space and there's no gravity and she's floating upside down and her head is this way, the starburst is still going to be able to move down into her stomach because of peristalsis. Okay, if you didn't have peristalsis, it would just come back out into the spaceship or shuttle, whatever you call it. So I'm going to show you a picture of this video, I guess. Maybe. Oh no. Say it so. Cross your fingers.
Come Donuts. State-of-the-art labs. Hands-on practice. More hands-on practice.
During the first swallow of thin liquid, all material is
I'm just going to show you. Alright, so up where that number 2 is, you see Carly swallowing? You see that? You see it swallow and it moved down, right? See if he swallows again. You see it swallow? Alright, now look. Look at, you see the wave like? See it squishing down? See it? Here, watch out. Look at it move down. That's why we can send her to space. And that's why you don't feel your cheeseburger just flopping down into your stomach. Is that cool? Alright. Let me show you one more thing. Alright.
Everything's open.
Huh?
He's the one that
What are you doing now?
What was that for, Rocky?
Is there a Charlie horse or something?
That was weird.
He is a
Digestion
crazy
begins in the mouth.
Okay, I know this voice is kind of annoying, but listen to all the vocabulary, okay? Excuse me, can you do that in private? Thank you.
My God.
Teeth, tongue, and saliva. The sharp-edged teeth tear and rip the food, while the premolars and molars, which have flat surfaces, grind the food into smaller pieces. That is the mechanical digestion of the mouth. Saliva is released into the mouth to begin dissolving the food and to make it slippery so that it can pass easily through the throat and esophagus. This is the chemical digestion of the mouth. The tongue helps to push the food between the grinding teeth and to mix it with the saliva. A ball of food called the bolus is formed and then swallowed. Muscles in your throat force the food downward. A flap of tissue automatically closes off the trachea or windpipe. This is a tube that leads to the lungs. It is required to get air into the lungs during respiration, but water or food is not wanted down this tube. After swallowing, the epiglottis goes back to its normal position and the trachea is once again open for air. The food moves into the esophagus, which is a tube leading to the stomach. It takes about 7 seconds for food to move down the esophagus. The lining of this tube is coated with slippery mucus. The food is pushed along because of muscular contractions called peristalsis. Contractions behind the food push it forward. Food doesn't move down through the digestive tract because of gravity alone. Astronauts in space can digest food even in weightless conditions where there isn't any gravity because of the muscular contractions of peristalsis. Food moves from the esophagus into the stomach, which has a capacity of 2 to 4 liters. The stomach is made up of 3 layers of muscles that create a grinding motion. The churning of the stomach is the mechanical digestion, and at the same time, gastric juices are released into the stomach to carry on chemical digestion. The mechanical digestion helps to mix the enzyme pepsin and hydrochloric acid with the food. The pepsin and hydrochloric acid help to break down proteins in the food into simpler proteins. You've probably used hydrochloric acid in science class to conduct various experiments. You know that this is a strong acid that can easily burn through clothing. How does the stomach protect itself from this acid? Well, a mucus is used to coat the walls of the stomach. After about 3 to 6 hours, the food continues to move along through the digestive tract and from the stomach enters the small intestine. The food, which is now called chyme, is in a soft, watery form. The small intestine is anything but small. It is only about 3 centimeters in diameter, but it is 7 meters or about 23 feet long. Imagine this garden hose, which is 7 meters long, all curled up and folded around itself inside a human being.
Pretty long, huh?
The food is pushed
Just the
along
small
by
intestine, that's it.
peristalsis and will now undergo major chemical digestion. 2 organs that are located near the small intestine, the liver and pancreas, will provide intestinal juices that will aid in this digestion. The liver is located to the right of the stomach. One of its important jobs is to produce bile, a substance that will help in digestion. However, bile is not an enzyme, but rather a salt solution that breaks down fat into small fat droplets. Then enzymes in the small intestine can work on the fat. When the bile is made, it is sent and stored in the gallbladder until it is needed in the small intestine. The pancreas is located between the stomach and the small intestine. It manufactures a substance called pancreatic juice. This juice contains many enzymes which will act on the chyme. The pancreas also produces sodium bicarbonate, which will neutralize the acidity of the chyme as it comes from the stomach into the small intestine. It takes anywhere from 3 to 5 hours for food in the small intestine to be digested. The proteins are broken down into amino acids. Carbohydrates are broken down into simpler sugars, and fats are broken down into fatty acids and glycerol. These nutrients are ready to be sent to the living cells of the body. To do that, the nutrients must be absorbed into the blood vessels of the circulatory system. The circulatory system, with its network of blood vessels reaching every cell of the body, will be the transport system. The walls of the small intestine are not smooth, but are actually covered with millions of small finger-like structures called villi. The villi contain small blood vessels that absorb the nutrients. These millions of villi increase the surface area of the small intestine 600 times. That translates to an area the size of a tennis court, ready to absorb nutrients into the circulatory system. As the food continues on from the small intestine, it is now made up of undigested food and water. Before entering the large intestine, the undigested food passes by a finger-like organ called the appendix. The function of this organ is not clear, but scientists believe it has something to do with helping the body fight bacteria and viruses. The undigested food moves into the large intestine, which is shaped like a horseshoe and fits around the small intestine. The large intestine is wider than the small intestine, with a diameter of about 6.5 centimeters. However, it is only 1.5 meters long. Over the next 18 to 24 hours, most of the water contained inside the undigested food is absorbed. Also, helpful bacteria living in the large intestine make vitamins K and B for use by the body. Finally, materials that are not absorbed are formed into solid waste. This includes such things as dead bacteria, food roughage, fat, and protein. This waste will move into a small tube called the rectum for storage. Then it is eliminated from the body through the anus, an opening at the end of the rectum.
I know that's kind of long, but you guys can handle it. Okay. Let's together try to label this. Okay. Yeah, let's label it, and then I think on your notes, like that packet of worksheet, like the packet of papers, you know what I'm talking about? The word search and the bubbles. I think we have one that's like really, really similar to this. Okay? Let's do it together. What would this be? The stomach. What would this be? Esophagus. What would this be? It's pointing like right here. The pharynx, yeah, the pharynx. How about this, under your tongue? Yep, salivary glands produce saliva. Okay, what's this big thing? The liver. What's its best friend? The gallbladder. Okay, how about all this in the middle? The small, good. On the outside? The large. What's this yellowy, whitish, what is it? The pancreas, yeah. Pancreas sits right under here. All right, what is the, right here where we are going to remove water? Before the rectum. The colon. Then the storage, oh, I gotta go. Rectum, and then pooper shooter. Anus, yeah. Exit, anus. Good. Is that all of them? Well, you guys did good on that.
What about sleep?
spleen. It's not on there. Well, that's intriguing. Yeah, it's not on there. Alright, let me show you which pictures. Here it is. I want you to do this one. Okay? And this one. This is your due by midnight. So if you don't get to it today, that's fine. So this and this. And then I want to go out and finish Callie. Then we're going to do a tiny little something with that. Okay? Yeah. Alright.